is being actually looked upon on a typical mobile device. So moving to the next slide, in terms of the OWASP top 10 mobile risks. As I said, typically when we talk about vulnerabilities, OWASP talks about the top 10 vulnerabilities. But however, we do talk here about the top 10 risks because they have not been yet classified as a vulnerability, and that's where we get into a kind of stuff that definitely these are still risks. So we'll go through on the top 10 risks where in detail in terms of what are the different types of risks. As you see, there are insecure data storage, the weak side server controls, insufficient transport layer, the client-side injection, poor authorization or broken authorization and authentication, improper session handling, security decisions via untrusted inputs, side channel leakage, broken cryptography, and sensitive information disclosure. So moving on to the insecure data storage, which talks about typically I'll explain you what the slide contains about. This is the typical slide content for all the other top 10 vulnerabilities. We talk about a threat agent. So what is a threat agent? Where is the threat being come from? What are the attack vectors? How is the what are the different types of attack vectors we have? What is the exploitability you have? Is it easy, or what kind of exploitability has it? And what is the security weakness, whether it is a prevalent weakness, whether it can be detected that the weakness is available, and what is the technical impact. We do also have a business impact, which typically depends upon what kind of business flow we are into, which has to be looked upon. So as a security test engineer, we cannot say specifically that we have a vulnerability, we have a risk, it's a high one. So how do we classify it as a high, low, medium? So a lot of math undergoes in this particular stuff, where we talk about how easily is it attackable, exploitable, in terms of how easily it is exploitable, and how is there a proof of concept where we can actually say that we can fix it, or is it in terms of it's an unconfirmed stuff. And when we talk about when we do this, we get into a common vulnerability scoring system, which is typically the version 3 in the beta mode, but we do take the beta, the 2 version, which is more rock solid, and give a scoring system to it. So that way it gives us more information on it. So moving on from that, in terms of what are the insecure data storage? When we talk about insecure data storage, how is the data being stored in the mobile for that particular application? So maybe when this particularly happens, when the developer does think about that there is not much of information available in this particular application, and at the same point of time this application can be stored in a phone file system, so that way nobody has access to it, or a file system which is not really breakable. But typically when you do a routing or a jailbreaking of a particular device, that would actually inflict the problem, where it says that the application data can be hooked up to a particular laptop or a phone, and we can have information onto it. So the threat agents would be the stolen devices, or the lost devices, or a possibility of a malware in the device, in the phone, or an application which is behaving maliciously for it. So that's where it gives you more of information. That's why it gives you more of information, and the impact would be very severe in terms of whether the authentication is impacted, the personal information. If you store credit card data into it, or an application data, that would be lost to the attacker. Moving on to the next slide, where are these usually available? What are the usual suspects of it? Where do you get this information? Specifically in SQLite databases, log files, the plist files, the cookie stores, SD card, wherever the cloud sync is happening, or the metadata files or the manifest files, which are known as the typical usual suspects for us. So when we move on to the next slide, typically for a couple of the vulnerabilities or risks, we have put on some best practices with respect to iOS and Android. However, with Windows or BlackBerry, we haven't yet done something. So with respect to the iOS, when we talk about it, we never have to store the credentials on a phone file system. You have to specifically use a standard authentication, web or API login authentication to the user over a secure channel, which would allow us to make sure that there are proper timeouts and session management happening, to make sure that we have all the information in place and every information is not being accessed upon. So in terms of when you feel that the data is very small, you can use a keychain API, but as I said, once the phone is jailbroken or exploited, you can specifically have access to all the keychains. And for the SQLite, you can have a data encryption or an SQL cipher, using an SQL cipher, which would actually keep all the data encrypted. And for the items stored in the keychain, we have to leverage the secure API designation, so that way we have information on it. Typically, now the devices are able to enforce the strong PIN, not the four-character stuff, but also multi-character, which would allow us an alphanumeric one, which would allow us for more secure authentication. And in terms of use the Apple's file protection mechanism, which should be used upon, so that way it will help us out in terms of doing stuff. And we talk about Android specific best practices. As I said, in terms of the specific device administration API, it should be used to force encryption to local file storage, where you can say specifically set storage encryption. And for SD card storage, you can use a Java crypto library, which would also give you some kind of security in terms of it. So, and you would also make sure that all the properties are not word readable. So that means you don't store it in the file system where it is pretty easily readable. So one of the key takeaways for the security test engineer is that he looks upon these particular places whether the usual suspects or what are the best practices have been passed upon. So when you know how the development team does the development of an application, whether it is secure or not, the test engineer can look through it by seeing whether the best practices are being followed and whether the usual suspects for this particular risk, are they available or not, or are they being actually properly secured. Moving to the weak server-side controls, the second risk, which it is, specifically this threat agent applies to the backend services. Here we talk about whatever, at the end of the day, the mobile device gets synced up with a web server or with a server-side control. So the mobile may have an interface to it, and if it is a mobile web, the mobile web will still go and hit the server side. So primarily any kind of vulnerability for the OS top 10, like the SQL injection, cross-site scripting, these all fall into place for this. So the weaknesses for it is typically the web world weaknesses. Since we know specifically that these weaknesses have been existing from the last 2005. So around a decade back, we are now secure enough to understand it, and we don't repeat the same mistakes. But as a security test engineer, we need to look through. It's not granted that we don't need to take it for granted that the web application vulnerabilities have been secured, so there are no vulnerabilities on the web side of it. Typically, you have to check for an XSS if it is a field is available, see whether the validation is being happening in the right perspective or not, whether it is a SQL injection, whether you are able to access the databases through an injection method. So typical impacts of it is your confidentiality is being lost, your integrity of the data cannot be trusted. So the business impact for this specifically is that loss is always there for the brand and reputation. So when you talk about it in terms of when you talk about it in terms of looking at it from the business perspective, the brand reputation is at a large from typically from a mobile standpoint than from a web standpoint, because a lot of things from the mobile, it's pretty easy. As soon as you download an app, you look through it, you have a lot of people accessing the mobiles, and once the number of people or the population being accessing the mobiles is pretty high. So that's where you would look through it as the impact for business is pretty high. As I said, the usual suspects, check for all the web top 10, the cloud top 10, look for it because web is a part of it, and also cloud because a lot of things get synced to cloud from the mobile standpoint. So check both of those, that would give you a stuff. As I said, the prevention tips in terms of make sure that what is the application being done and what it is actually bringing onto the table, and whether the backend API services or the platform are secure enough, and all attack vectors, because all the attack vectors are from the web world and the cloud world, so we are all well known for it, so we need to understand it in a much better perspective. So moving on to the third one, the third risk, the insufficient transport layer protection, which is typically where you have a lot of problems. When we talk about it, the insufficient transport layer protection, the applications, there are a couple of applications which are devised. When through a 3G, they say that you go through a Wi-Fi or a secure, when to a 3G, you go through a secure connection, but whereas through an Wi-Fi, you don't go through a secure connection, because there is an assumption that all the Wi-Fi are secured. But currently, the way the mobiles are being used, you can definitely use it at a kiosk, you can use it at your airport, where there are no secure channels, or your cave. I don't think there would be any security in perspective in a cave where the Wi-Fi is allowed for free. So when your application typically switches from a 3G to a Wi-Fi, the secure connection will get switched off. So that way you are putting the data in transit in a kind of high risk zone. So these kind of stuff is pretty difficult to actually look upon, and these impact a lot of both from the technical perspective and the business perspective. There is a lot of impact to an individual and also to a particular organization, and specifically a lot of attacks can happen through this. So who are the usual suspects? In terms of the usual suspects are the connections, not you are basically owning it, the SSL certificates, whether they are date, are they self-signed, or they have the enough cipher strength, would you check for it, and any particular the application will accept any certificates as authorities. So whether they are following the right stuff is not, you have to check for, which is typically you as you check for a particular website. So moving on to the prevention tips, as I said, we need to enforce SSL and TLS at all transport layers, all transport channels. All stuff should be being to a secure thing, and any third-party companies should also be using an SSL session, so that the user session ID should not be exposed at any point of time. Strong and industry standard encryption algorithms have to be put in place. Your security provider, the CA provider, should have a signed security, and it should be a trusted one. No self-signed certificates. Never ignore or disable SSL because for the for the comfortness or a kind of assumption that the wireless through the Wi-Fi it would be secure enough. And you have to, whenever you get an exception saying that this particular certificate is not valid, you need to take utmost care that yes, this should be looked upon, and no specific sensitive data should be sent through any particular channel like SMS or notification, where there is a possibility of getting the traffic getting sniffed and having more information to it. So typical best practices in iOS and Android which can be used so that we have a specific all the certificates being enabled. So if the certificates should be valid, and it should also be fail closed so that there is no issues on it, and all the default classes in iOS will handle very well all the SSL negotiation and cipher strength, so that can be used upon. And specifically for Android, we should remove all the code with the development cycle and allow the application to accept certificates from a host name which is verified. So that's how it has to be done in terms of the best practices. So moving on to the next slide is the client-side injection. This is typically when a particular SQL injection, how can it be happening from this part of it. We do test it from the second vulnerability or the second risk, but at the same point of time look at it on the client-side injection, how it has been happening, whether the server-side verification is happening or is it happening only at the client-side, the verification. So in terms of how the data is being injected for this particular what is the source? Any source can be a data. Any source of data can be an injection vector. So how it is being injected is we should be able to look for it. So we have to understand the injection attacks, and the impact would be depends upon what kind of application you are using and what is the data which is trying to get. What kind of information it is being, is it allowing you the user database from your any data being stored at your phone, is that being used, or any application or anything which is being paid, paid content is being accessed without your notice. So the usual suspects is the data on your device, the session, the mobile user session, and what are the interfaces or the function for that particular application. So specifically iOS specific stuff, as I said, SQLite injection should be taken care of. All the queries which has to be parameterized. Whitelisting has to be done. No special characters can be included on a particular login form, so that we would have specific authority in negating those stuff. Look at different kinds of injections, JavaScript injections, whether they are being applied filter for it. Specifically, look for validation stuff. Whitelisting of it would be very, very good, so that you would not get any information out of it. And also when classic C is being used, the most of the old C functions are very vulnerable, and it is well known. So avoid to use these functions which are very vulnerable to the injections. And with respect to Android, the top three would still be the same in terms of SQL injection. All parameterization should be done. Anything it is, any JavaScript or plugin support should be disabled, or at any point of time whitelisting of that should be done so that no specific characters will be get into it. And at the same point of time, local file inclusion is being disabled for web views so that they don't have access to any particular local file when trying to view through the mobile web world. The fifth one, the poor authentication and authorization risk. It's basically why it is a poor authentication and authorization. Simple thing, it is because the application do not use strong authentication and authorization schemes. They do use your phone number or your IME number or your unique identifier, unique user identifier as the actual authentication purpose of it. So the whole purpose of the stuff is defeated. For example, if you are trying to get authenticated for a lost or a stolen device and the SMS is being sent to your device itself, so it's already lost and you are being compromised, so you have the information because you can quickly pick up your UID and send it, or the application itself picks up the UID or the IME number of the phone and sends a third-party token for you to an SMS where your SMS is already being compromised. So this would actually give an information onto the attackers, and at the same point of time we do have specific authorizations and authentication items which would make them fail and the data being wiped out of the device. So that would also be a problem for us. So the usual suspects for this is typically the apps are left at the mercy of the mobile device. You need to actually have a strong authentication and authorization man, so that way it's not left at the mobile device itself. And never use the device ID or the subscriber as the sole authenticator. It can be used as one of the part of it, but it should not be used as the only part of it. So moving to the prevention tips, it would specifically implement the user authentication and authorization and session management correctly, and you have to authenticate all API calls to the paid resources. Paid resources in terms of any resource which you are paying for it, an application which is trying to access your Skype phone or something which you are currently used as a paid application. So at that point of time, it could definitely give a lot of it would actually give access to your paid resources, or at some point of time your app store purchases are being happening without your notice. Application, whenever you click something, it would be able to purchase an app store stuff, so that would also be a problematic stuff. So typically when we go into an iOS